Hey guys, welcome back to the channel. I got a little time. It's Friday afternoon. It's been a long day, a very hot day, but I got a little time to spend. I thought I'd make this kind of curious about the inside of this here Sencore Handy 75 that we spoke about briefly on the last episode. So I'm going to kind of break it open a little bit. I'm going to just kind of check those. I think the gentleman, I don't remember what his name was now, but I think he called them sand domes instead of can domes, sand domes. Because it looked like to me they're made of sand. So anyway, let's check all that stuff there, and while we're at it, in fact, the electrolytics knob here just frozen. We'll see if I might be able to get a little bit of jet oil or turbine oil in there, but all these capacitors in here that just need to come out. I'm trying to be careful with this thing. Get it out. Come on out, there we go. There we go. Got us a mess here, boys and girls. Now, I have not found an exact manual for this cotton picking thing. Believe it or not. What is that? I do not know. I don't know if that's even supposed to be in there. I guess it is. I think that's what holds all this stuff down. I don't know. Bunch of stuff in here. I just really don't know. Excuse me. Reach over and get my new glasses. Among the things that I got the other day at the residence of the gentleman that had all the stuff at the flea market was a Fluke 77. It's a little dirty. I haven't cleaned it yet, but this thing works fantastic. All I did was put a battery in it. For what I paid for all this stuff and what I got a sweet deal. I don't know what the values are of these sand domes. Let me zoom in if I can figure out how to do it. There we go, a little bit better. These are the sand domes right here, as a gentleman told me, and they kind of, you rub them, they kind of leave some sand. But these little white dudes right here, they look like the old dog bones, but he called them sand domes. So we're gonna call them sand domes because I don't know any different. There are 4 of these in here. They have markings marked 15,000, 1500, 150, and 15. It's 15,000, 1500, 150, and 15. I think that's total resistance, perhaps. Let's find out. Tell you what, dude. Let's see. There you can see the meter, I think. Yeah, hope you can. Let's see what happens. Got to work on my. Got this dude a little too hot the other night. Working on another project. Hard to find any of these things that's actually good. I'm going to see if Pomona has these. Pomona makes some of the best test leads and clips and everything that there is. So it's China crap. Let's see what it measures. It measures 16.55 kiloohms. Safe bet to say that that thing is probably good. We got 4.87, 7.85, 5. well, let's see, 6 point something or other, 6.5, 6.6, 6.7. That one's good. That's the 15. I think it's going to be good. Looks like all these are common. I'll just put my comment on there. Let's go to the next one. I'll just go to the end. It's going from one end of the resistor to the other. This one's marked 1441 ohms. So more than likely that one's good. Let's go down to the one. Next one should be 150. It measures 163.8. And finally, I think the other one is 15. Measures 16.3. So we're good with the stand-on resistors. Check okay in this thing, which is good. That's good. I don't not figured out what this is. Just not right. There's something's just not right about this. Hang on just a second. I think this thing has been dropped. See all this fish paper stuff? I think I know where this goes. I didn't know where it went at first. But if you can see, my little Chinese pointer, this little piece right here, a little silver piece if you can see it, that I believe is the hold down for these. And I believe that all this fish paper that goes in between those acts as insulators. So I'm going to see if I can figure out how to put that back together. I'm going to assume that this is the bottom. Sure. Not sure which way this goes. I don't want to push this stuff too much. I can assure you that is not supposed to be there. So instead of y'all listening to me ramble on figuring it out, let me see if I can figure this out and I'll bring you back. Okay, after messing around with this, I believe I found the orientation of these things. However, this thing has been this little keeper right here, it's riveted to the front of the chassis. I don't know how well you can see it, but let's go gorilla style for a minute. I'm actually working on some better camera equipment, y'all. I'm ready to take the next step. And this is what I was talking about. This is that clip right here that's riveted, if you can see it. Right down in that hole. Yeah, there it is. There's a rivet. There it is, right. I'm sitting here pointing at the screen. Right there. It's a rivet, but this thing has been pried out, and I can't get it to. I can't get it to hold this thing down. If you look very carefully, let me turn this thing around. If you look very carefully, this is how I know where it goes. Let's see where it's right there. See that little indentation? That's where this went. But this has been sprung back. So, in order to make this thing factory, I'm going to take this to my other shop, drill that rivet out, straighten that out to give it spring pressure again, and then I'm just going to put a screw on there. I know it's not factory, but that's what I'm going to do. So I'm going to cut you loose for a few minutes. I'm going to take it out there and drill that out, straighten it up, put a screw on it, a machine screw on it, and see. I'll bring you back when I get it put back together. So be right back, hopefully. All right, just a real quick one on this one here. This is the little bracket that I pulled out. And it a little bit out of just a little bit bent. There was no way I could put, with all that stuff in the way, no way I could bend this back. But basically, I'm going to bend this piece here back straight, And I'm going to bend this one, put a little bias on it, bend it a little bit down. That way I'll give it positive pressure when I tighten it down. So once I get all that done and hopefully get it back together without breaking those sand domes, I'll bring it back and we'll move on from there. Okay, is it running? Yes, it's running. My Lord. my gosh, what a battle. Let's see, get y'all people straightened up. I got it. I'll get a little closer there. That's the way it should be. Now I just got to clean up the wiring on it, straighten all the legs on it, and make them look right. That's the way it should be. Let me show you something. What gave me a clue to the location of this was on the case. Another clue, should I say. But on the top of the case right here, wherever it may be, there's a slot, open slot. Those resistors fit through that slot. If this lip, I guess you'd say, was on there, you'd never get that thing on and off without tearing it up. So I'm confident, happy that that's good. So I'm going to straighten these pins here, make it look good again, and I will bring you back and we'll start checking some resistors. I'm pretty sure all of them will be bad, but I will bring you back in just a few minutes. Of course, it didn't help any in this when I forgot to put the bottom fish paper on, the main one. Don't y'all ever, I know, gotta get this all straight and make it look pretty now. Everything to line up is so-so. You gotta be careful with these things. You know, these things look like they're fragile. I mean, if they're sand based, I don't know what's inside them. I know it's wire wound resistors. I know that. Alright. Finally. Then we'll straighten the leads out on them. Clean this up, make it look pretty. Remember, kiddies, if you're going to bend these legs on these things, support them with your finger and don't move them too drastically. You could damage them. All these things have no insulation between them. If I really wanted to, I've got some Teflon sleeves that I could put on here. Yeah, that looks better. I don't know, I think this thing must have got dropped. Okay, that's good enough for now. I wish I kind of had to pull these capacitors out. So just throw them in here a minute. I want to see how this thing fits back in the box. All these capacitors got to go a certain place. Oh yeah, there's how you. And I may have my fish paper upside down. That'd be special. I may have, because this is touchy. I don't know. If I don't put insulation on that, it could rub the top of this. I'd rather it been on round both sides. but I think I can get by with it being on one side. So once again, I got to take it apart, change it. Alright. That's a little better. Now, when I put it in, it's protected. There's nothing for it to touch on the back side of this that I can see. So, but this side here would rub against that and it would eventually short out. And I don't want this thing to be a hot chassis. Okay, so I got the candomes, sand ohms. So let's check it one more time. I'm going to zoom you out a little bit, let you see the meter. Looks like you can see it. We'll check it one more time. This one is 15. Okay, that one's good. 1500. This is 15,000. Measuring 16,000, which is fine, I would imagine. And this is a 1500 measuring 1400. That's good. Alright, this one's 163, should be 150, but I'm pretty sure this is 20% or more tolerance. And this is 16.3 ohms, which should be if the resistor's marked 15. So that is good. We have that in place now. That is the proper way that these things mount. I'll stake my reputation as a heavy eater on it. Anyway, that should be correct. You have fish papers that's going in between the resistors. You insulate the resistors from each other, and then you have the big one here that folds under and goes underneath all of them, so it is protected from short circuits as far as grounding and adjacent in each other. The only thing is these leads here are not insulated, but you just have to be careful. And like I said, I might go back in and change that, but I think it's fine. So the next thing is, I guess I'm going to drop some oil on this switch here for this capacitor, see if I can get it to free loose. So I'll bring you back when I get to the next step. Okay, one quick thing. I always talk about turbine oil. This is what I call turbine oil. It is certified there, but I don't know what the viscosity is of this. I've had this forever, but I know it's turbine oil. Now, honestly, I don't know what the viscosity is, so I don't know exactly what this is. I've been meaning to look this up, but it's a very thin oil, and it's perfect for these, and I love the needle point on this thing. But I'm just going to put a little bit of oil down here in the switch area where all the mechanical section of that switch, and also this is the one I actually needed. Let's see if I can get it in there. Just kind of get it in there, let it soak a little bit. Usually what happens, these things get gummed up. It's not really rust, more like the lubricant that they use, the grease, hardens up. And what you can do to ease these things up, if you don't want to take them out, is of course take the knob off. Take the knob off the shaft and take you a soldering iron. Soldering iron, and or you just put it, these are aluminum shafts, so you don't have nothing to worry about, but put a soldering iron right on this shaft like that and leave it there for a minute, and that'll warm that grease up and heat that grease up to where you can move this. And then as it starts moving, you can add a little bit of solvent or a little bit of oil in there, and it will it'll dislodge that grease. But the bad part about that is it's still got that grease in there, and it's still likely to gum back up at a later date. So your best bet is to use a solvent. I would probably pull, this switch is completely autonomous from everything else in here. So I would pull this switch if it was me, excuse me, and get it away from your circuit, your box and all your artwork, and put a little solvent in there and work that switch back and forth very carefully, because you're not going to find another switch like this. But anyway, I've got this lubricated. I'm going to put the knob back on it. Let me just see if we get any kind of action. Look at there. That little bit of turbine oil did it. Yay! Now all these switches are going to need contact cleaning, and that's another issue right there. We'll get to that when we get to that. But you know, the switch works. Didn't have to take it apart. Awesome. Alright, so the next thing that I'm going to do, or the next thing that we're going to do, I'm not even going to bother checking the capacitors. I know these capacitors are bad. I'm not even going to even worry about trying to figure them out, as far as, you know, put them on a capacitor tester, see which one's good, which ones are bad, and I sure as heck ain't going to reform them. Believe me, all these capacitors that I've taken apart and restuffed, and I've seen what they look like inside, you can put the reformed machine on it for 50 years. If the electrolytes dried out and no more, not there anymore, it's really pointless. Really pointless. Yeah, if y'all want to reform them and y'all believe in it, hey, so be it. I'm not going to sit here and tell you not to. I just personally, I believe it's pointless. Anyhow, check some resistors. Alright, get y'all just a little bit closer. Let's see, can we both see the ohm meter? Yep. Well, let's check some resistors. There's a common ring right here, if you can see it. So I'm just going to put my ohm meter on the negative terminal, because that seems to be common. I tell you what, it would probably be easier if I just used the switch to do its thing. So I'm going to get a little bit of deox to put on these switches and this rotary switch, and spray them, and we'll just check them for the front panel. That way I ain't got to individually do each resistor. Okay, these switches are the kind that you really don't want to take apart. Matter of fact, if you don't have to do it, in other words, I can't get to the switch components with my Brasso or my what is that stuff, Tarnex, to go in there and wipe each one of those and get rid of the tarnish on them. I couldn't do that. You don't want to put Tarnex in here and leave it. This stuff will eat it alive. So my only choice was the deoxit route. This is D5, deoxit D5. Not the gold or nothing like that, not Fader Lube, but just regular deoxit D5. Now, about empty on this one. It kind of drenched it, turned it a little bit, but the other thing that I did, and it's really a no-no, but on these slide switches right here, let me bring you in a little bit. One thing you really should not do is spray these slide switches with any kind of stuff like, and this is what I did. I should not have done it. I don't use deox on these slide switches because the slide switches are a fiber, a very soft fiber, and if you spray them with deox, like this dummy here in this camera, they will warp. and a lot of wafer switches, a lot of the older wafer switches, if you spray it with deoxit, it will warp them, it will damage them, and you have to dry them out, or take you a little while to dry them out. Anyway, these wafer switches, just use regular contact cleaner that you can get, or from your automotive, your favorite automotive store, or Harbor Freight, places like that has good CRC contact cleaner that's plastic safe. Anyway, I sprayed the switch just because I was gung-ho, and now it doesn't want, the plastic is swollen on it. The fiber is swollen, doesn't want to operate properly. So that's my fault. Don't do what I do. Anyway, I have the ohm meter hooked up. Let's move on. Have the ohm meter hooked up, and I have the selector switch, and y'all can't even see what I'm at. Where am I? Right there. Sorry about that. Let's see if I can get a little more zoom. I actually need to see the camera. Either see the camera. Oh my gosh, what am I smoking? I notice I do that a lot, but my mom was like that, and I've just gotten away. I've just gotten her routines, guys, and I'm not going to complain about my mom. I miss my mom dearly. I have a lot of her. I have a lot of her ways, and I'm going to tell you this, and I'm going to move on. But if your mom is still alive and you don't go see her, do yourself a favor. Put down whatever you're doing. Call her on the phone. Go see her. Spend time with her. Because I didn't really do that with my mom, and I wish 1,000 times a day that I would have. But anyway, I didn't mean to digress. Watch your mom. Watch your dad. Anyway, I'm on R times 1 on the selector switch right here. And I am selected on the 10 ohm function. It's 10, 18, 33, 56, 100, 180, 330, 560, 1K, 1.8K, 3.3K, and 5.6K. And if I flip the switch over here, then all that's time 1,000, which would mean that's, what's that, 10,000? Yeah, 10,000, 18,000, 33, 56, 100,000, blah, 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 blah. Anyway. 10 ohms measures 13.8. The 18 measures 22.1. The 33 measures 41, almost 42. The 56 measures 67. 100's 134. The 180 measures big old 236.3. 330 measures 357. The 560 measures 657. 1K measures 1,000. The 1.8 measures 1,940. 3,300 ohm measures 39.6 or 3.96, and the 5,600 measures 6.3. So as you can see, some of these are a little bit out of tolerance. So anyway, let's start back at the 10, and let's switch this to R times 1,000. So now we're at, this should be, I think, 10,000 ohms. Measures 10.96K. The 18 measure 18.6K. So far so good. The 33 is measuring 38. Let's see, the 56 is measuring 58. The 100 is measuring about 117. That's within spec. 180 measuring 187.8. That's fairly close. Where are we at? 330 is measuring 375. Alright, the 560 is really up there, measuring 760. The 1K is measuring, I'm sorry, the 100,000. Wait, 1,000. That's one mega ohm. 1 mega ohm is just 1.18. The 1.8 meg is measuring 1.9. The 3.3 is measuring 3.73. And of course the 5.6 meg is measuring 6.56. So there you are. I think these are all carbons, just like all Allen Bradley style carbons. Looks like a little booger to change. So that'll be a fun little project. Take lots of pictures if y'all want to do something like this. Anyway, I think the next thing I'm going to do is measure the wire wound resistors. I haven't cleaned these controls yet on this section. Probably ought to. It looks very dark. Looks very, very black in there. That's the same kind of switch. I don't know the name of these switches. I've seen them forever. They're little booger bears. They're a little pain in the butt to keep clean and work. If somebody knows a better way, I'd love to know it. And I got that all over them canned sand-ons. Oh well. Life's a bitch and then you die. Alright. I'll just get the heat gun after a while or tomorrow or something. It'll be fine. I'm just going to spray regular contact cleaner. Regular contact cleaner on the slide switch. I won't make that same mistake twice. Get in a hurry and run in my mouth sometimes, you know. Just give it a couple of toots. This stuff flashes real quick. See that switch? Hear it click, 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 click. That's what it's supposed to do. When I sprayed that other one, that deoxit, it swole up. I doubt that switch will ever be the same. But I'll let it dry for a day or two, or maybe till tomorrow afternoon or something. And then I'll come in there with a heat gun and see if I can dry it. Okay. Got that one cleaned up. Here we go. I'm showing infinite for some reason. Or should I say open? Get this thing to stay on there. There we go. Okay. We're on the wire wound resistors now, and 20 watts, which is the sand ohms. So we got 2.5, 5 ohms, 7.5 ohms, 10 ohms, 15 ohms, 25 ohms, 50 ohms, 75 ohms, 100, and 150. Then you switch the switch to the right, and it puts it times 10. So let's check the R times 1 function of the wire wound resistors. If you can see the meter. Here we go. This is 2.5 ohms measuring 2.4. Fine. The 5 ohm is measuring 5.6. That's fine. The 7.5 is measuring 8.2. That's perfectly fine. The 10 ohm is measuring 11 ohms. The 15 is measuring about 16.4. And then the 25 is measuring a little bit out of spec there, measuring about 37.9. That's interesting. 50 ohm is measuring 61.3, and then 75 is measuring 83.1. And I think all these things are in series. There's just adding to. So I have a feeling the 15 checks good, but the 16, the 25 is measuring 12 ohms high. 50 is measuring 61.2, so that's almost 12 ohms difference. So between the 15 and the 25, that junction there, that resistor is not quite right. is affecting all the other ones on here. So what I'll probably have to do there is probably find that resistor, find out where the junctions are. Oh, Lordy mercy. That's interesting. Normally I would just jump a resistor across it. I would jump a resistor across it, but let's check the other ones. I'll figure this out later. Going to R times 1. I'm sorry, R times 100. So this should be 250 ohms, measuring about 290. This 5 is measuring 521. This should be 750, which is 745, as you can see. And then the 1000 is measuring 983. That's fine. This 15 should be 1500, measuring 1443. 25, here we go. This is 26. That's okay. And the 50 ohm, I'm sorry, yeah, the 50, that should be 5000, measuring 6000. This should be 7500, measuring about 87.9. 100 ohm, I'm sorry, that's 100 times 100. That's 1000 ohm right there. Wait, that doesn't matter to me. 1000, I'm sorry, 100 times 100, 10,000, stupid. 11.8 kilo ohms. And then 150, it should be 150 times 100, that would be 16,000, yeah, 15,000, so measuring 16,000. So yeah, that's pretty decent. The only thing that I found is back over here between this 15, it's just about, that's within region, but this 25 right here, that's measuring high. So anyway, we have a problem there. So what I'll probably do, more than likely somebody probably run a little bit too much juice through there and damage that part of the resistor. So what I think I'll do is I'll just find a 25 watt aluminum wire round resistor, mount it to the chassis and bridge it between the 15 and the 25. In other words, I'll probably put a I'll put a resistor in parallel with that to make that resistance of 25 come down 10 ohms. So I'm tired now. I just figured up in my head. But anyway, so the resistors, I'll have to change all the resistors out in the carbon side and add one resistor to the wire round resistor side to get it back in step. The capacitors, we know those are bad. Excuse me. And the electrolytics for sure. So there you are. As far as the resistance and everything goes, we've got that repaired. Told you what not to do with these. Good Lord. Sorry about that. Don't spray these things with anything but fast drying electrical cleaner or switch cleaner. These switches here I use Deox on because I couldn't get in there with my Tarnex to actually clean those connections directly. So I used Deox at D5. Same thing on this switch here. I couldn't get it apart to clean the connections. There might be a way. I've just never done it. I don't feel like taking them apart, but the Deoxit seemed to have done its job. Then I sprayed this slide switch here with my CRC contact cleaner. And let's see here. Quick drying formula, leaves no residue, plastic safe. That leaves no residue is what you want. Anyway, the next thing that we got to do is we already checked these caps the other day, if I remember right. So those are fine. I mean, those may need to be changed, but I'm kind of curious now. I'm really curious. Let's set up. I'll bring you right back. Okay, we're going to recheck those caps because I don't remember what I found. But I'm going to check. There they are. I'm going to check these three dudes here. I'm just going to see how good they are. And what I'm going to use is my Sencore RC146 resolver capacitor inductor analyzer. This is one of the, from what I understand, is one of the standards or gold standards of capacitor analyzers nowadays. They may have been superseded by something else, but this thing is a Cadillac of capacitor testers. So anyway, we're going to test just normal everyday capacitors basically. So you would select the all other caps, and now the next thing that we want to do is do a lead zero. So I'm going to press open, lead zero, open, test in progress, done. And basically you just lay your test leads down, have them close to each other, but not touching, electrically. And then we want to, once we do that test, short the leads, press the short lead zero test. Now it's calibrated. Now your ESR readings, if you choose to do so. So the first one we're going to measure is a 0.5 microfarad 600 volt capacitor. So what you do is you come in here and put the value in, 0.5 microfarad 600 volts. You see the LED flashing here, that's telling you you're over 25 volts, that it could be dangerous for you. If you test this capacitor with leakage and you hold those leads in your hand while it's doing that, you will regret it. I'll just leave it at that. So I'm going to check the 0.5. Just got to get to it. This should be the 0.5. So we're going to measure capacitor value out of component test, out of circuit capacitor value. So here we go. Measure 0.5 microfarads. Okay, now we want to look at the leakage of this capacitor. So we press again the component test, out of circuit capacitance test. We wait. 0.36 microamps. This is a good capacitor. So I'm not changing that capacitor. It's perfectly fine. So now what I want to do, another one in here, a 0.05. This does not look factory, but it's a 0.05 at 600. So again, we come back up here, 0.05 microfarad. Anyway, we'll do capacitor value, 0.0491 microfarad. Capacitor leakage, watching this scale right here, 0 microamps, greater than 600 mega ohms. It hadn't said it's good, but the initial reading is what you want to look for. You don't wait on it to build up. It doesn't say it's bad, doesn't say it's good. When you let go of the capacitor leakage, it will discharge the capacitor. Once it says it's discharged, then you can safely handle it. That one, according to the manual, if you press this button right here, and it does not give you an immediate reading of good or bad, it is a suspect capacitor. Let's try the dielectric absorption. I don't think it'll work on this lower value, but we'll see. In other words, just checking that capacitor to see if it's acting more like a battery as compared to as a capacitor. A battery retains voltage. In other words, when you discharge it, you charge it. Basically, what it does is it discharges it, charges it, discharges it, charges it. And it says, it looks at how much residual charge is in there. But that seems to be good. We may leave this capacitor in there, even though you didn't really like it. Now here is a 0.1 microfarad capacitor. We're going to check it next, so we'll just come on here, enter the value, 0.1 microfarad. It's really self-explanatory. I love this meter. Now it's not the end-all be-all tester now, I will use the my Heath kit right next to it when I want to see absolutely sure. I want to look at that eye. If if I'm not quite sure if this is a little ambiguous, I'll use my Heath kit, which is next to it. Anyway, we got a 0.1 microfarad at 600 volts. So let's look at the capacitor value. 0.1010 microfarad. It's going to do leakage. We're waiting on it to figure it out. It's greater than 600 meg, but it hasn't said good or bad. It should be good or bad right here. So it's, yeah, there's no leakage on it, so more than likely it's good. But let's look at the dielectric absorption. You have more problem with dielectric absorption with electrolytics than you would this, but hey, it likes it. So I'm going to say these 3 caps are good. I'm not going to check nothing else on there. These other capacitors here, let me zoom you out. This is my other capacitor tester right here. This thing is a Heath kit model C3, and I put the chicken head knobs on it because the ones that come with it were the pain in the butt to use, especially for the switch right here. Makes it a lot easier to use. Anyway, this thing has its uses, and the C&I tells you a lot. I know Mr. Carlson's got that capacitor tester he's got and all that, and it's probably great, but honestly, if it's an old capacitor and I'm doubtful of it, I'm going to cut it out and put a new one in it. I'm not going to fool around. But I want to do one more thing. This video is getting long. I can tell you that right now. Just out of curiosity, I'm going to try to measure this capacitor here. It's 125, a 2. It's red, blue, black. 3 leads. I want to measure this thing. It looks like it's probably 450 volts. Yes, 450 volts. I'm going to measure this on my tester and see how it measures. So let's put the lead back on here. This thing stays calibrated as long as you don't turn it off. You want to clear your settings, start over, and I'm just going to recalibrate it. Come back down here, like chasing a cotton picking snake. Kind of act like one too. Alright, I press the short. Done. Now we'll want to set it up. Aluminum electrolytic component type, and we want to place 450 volts, 125 microfarad, 125 microfarad. So see, aluminum electrolytic, 125 microfarad, 450 volts. So we want to find the common of this little dude, and the common appears to be right there. And we find that little red wire in there somewhere, which is right there. So we'll just attach right there. See what it does. We'll go capacitor value. 15 microfarad. Let's just go ahead and do a leakage test. Ooh, we don't like it. Greater than 20 milliamps. Less than 22.5 K. There is a prom upgrade you can do on these LC103s, but I don't have the ability to do that, but I would like to get this upgraded to the latest version. It don't like that capacitor at all. Almost checks open. I'm curious why it didn't increase. I'm just changing the value over to something else. It could be some interference in the way these things daisy chain. Let's try that capacitance again. See, now we go. I thought so. 115 microfarad, 107, going all over the place. Let's see what the way this switch is wired. This may not be a compatible test. So, tell you what we'll do. We'll just knock my tripod over, step all over it. We'll just cut this lead. I'm not. Give me just a second. I apologize. It was either that or put you back on the tripod. I'll just let you look at my curve tracer for a couple of minutes. Okay, here we go. So the red is supposed to be the 125. I just cut the leads off because these things interact with each other. Now we can measure it directly. Let's try this again. Look at there. It's measuring 13.3 microfarad. It is that's a bad cap. Excessive leakage. It can't even test it. And like I said, according to the manual, if this thing don't give you a good bad right off the bat, it's a bad capacitor. You see, that's supposed to be 125 microfarad. It did not check that way. So this other one, let's check the blue wire. The blue is 2 microfarad at 450 volts. So we're going to change the value to 2 microfarad, 450 volts. The new capacitor value. Look at there, 0.5 microfarad. Do the leakage test. And look at there, it's bad. Greater than 20 milliamps of leakage. The resistance is below 22.5K. So that's bad criteria. That is a bad cap. So that's why we want to change these. Anyway, that's about it. About as far as I'm going to go with this thing tonight. I'm going to put it back up. And because hopefully tomorrow afternoon I got another project to do. We made a little progress on this, but thanks for sticking around. And just wanted to mess with this a little bit more. Hadn't been out in my shop in a few days. So anyway, I thank you guys. I thank you guys for, don't need to zoom in onto my face. I thank you guys very much for tuning in, and do a like and subscribe if you don't mind. When I get done on my other project that I got going on, and I'm going to try to record it too if I get started on it tomorrow afternoon. It's a secret. It's going to be a good one, I hope. Anyway, thanks for watching. Please like and subscribe, and I will talk to you next time. Y'all be good. Bye.